Hello again. So today I have this small little tuner which is used for shortwave radios. I had this for a very long time. It's been sitting around. I've been using it with my ICF 2010, the Sony, and just thought I would take some measurements on this to see its band pass characteristics, which is supposed to basically tune among different frequency ranges across the shortwave band, as well as in the medium wave and long wave. So I'm going to take a look at this, the response of this across these bands, and then show you some curves on the spectrum analyzer with using a tracking generator to sweep these different frequency bands and see how they look. So what we have here are multiple bands. Starting with the extreme left, you have a ground case where you basically the output is grounded, so no signal should get through. And then there's the bypass mode where the input just goes directly to the output without any attenuation or any filtering. And then you have the first band, which is the long wave band, which is from 150 kilohertz to 500 kilohertz. And then the medium wave is from like 0.5 megahertz to 1.7 megahertz, the AM medium wave band. And then the lower end of the shortwave band starting at 1.7 megahertz to 7 megahertz, 1.7 to 7 megahertz, and then lastly the upper shortwave band 7 to 30 megahertz. So let's take a look at the inside of this. It's fairly simple. As you can see, there's a big switch here which selects the different inductors, which you can barely see in this. It's buried at the bottom of the instrument here, and it's hard to see it. It's got coils which are, and they're selected using these different rotary positions. And then to the right we have the tuning, which is the capacitance of air capacitor, which then allows you to tune across each of these bands within that LC combination that gives you that band pass characteristics. So in the back is just a couple of connectors, which then also you have a ground for the black line, which is common to both connectors. So that's very simple block here. There's no active circuitry to resolve, to basically AGC the gain, so to speak. It's going to have losses, different losses at different frequencies, and that's what I'm interested in looking at, as well as to see what the curves look like across these bands. So what I'm going to show next is my setup for the tracking generator, which is on top, the spectrum analyzer. Right now I'm going to set it up and then come back to show you the different bands, including the starting from the ground all the way up to the maximum frequency. Okay, so now everything is set up. Right now I'm going to first do a full sweep from the minimum, which is 9 kilohertz for the spectrum analyzer, all the way up to 30 megahertz. And let's take a look and see broadly what happens. This is ground right now, nothing coming out. And I need to turn on the tracking generator. We can use 0 dBm. There's no active circuitry, so nothing is going to overload here. And turn the tracker on. So right now I'm grounded. So as you can see, there is still some signal passing through. The output is in microvolts in this case. So it starts from 100 microvolts all the way at 30 megahertz. It goes up to 2.7 millivolts. So actually my spectrum analyzer just calibrated itself, so it's going to have turned it off for now, so it doesn't interrupt this thing again. As you can see, it's about 2 millivolts on the upper end at 30 megahertz. The input is 0 dBm, which is 223 millivolts, so it's significantly attenuated. It's not quite the nanovolts or microvolts, but still. And now if I do a bypass, you can see it's flattened out at a much higher level, and that appears to be in the 200 millivolts, 225, and at the lowest frequency it's 266 millivolts. So it is, of course, this instrument does not create an accurate level either, but so just relative. So it's still very high. It's basically bypassing the input and unfiltered directly to the output. So next we'll look at the 1.5. I'm going to do a broad sweep again, then focus into the narrower band later. So this shows you the 0.15 to 0.5 megahertz. And if I tune the capacitor, you can see on this is extreme left, you can see a very sharp band pass characteristic on the left side, and then as I tune to the right, you can see that moving, and this is the extreme right position. It's also attenuated significantly at the higher end of this band, which is 0.5 megahertz. So it's actually not maintaining the level very well. So depending on where I tune the capacitor, moves around both in amplitude and as well as the cutoff frequency. So next band is 0.5 to 1.7 with the medium wave. So this is extreme left again. I'm going to zoom in later to show you where that exactly is. And so this is at the extreme left. So the peak appears to be at 660 kilohertz actually in this case. It should be a little bit lower, but appears to be at 660. As I go to the middle of the tuning dial on the capacitor, the peak appears to be at 1.14 megahertz, and it's dropped a little bit to about 140 millivolts. And on the extreme right edge of the band, it's significantly attenuated again. I think it's well past the medium wave band at this point, so probably not recommended to operating at this level. So this is over a couple of double peaks, and the peak is actually on the right side now, so I need to actually manually move it back. It's hard to tune this, but it's around 2.34 megahertz, which is well outside the medium wave band. So it's probably not a good idea. Probably leave it around here, which gives you still some decent signal, and it's, I think, probably at the edge of the band at this point at 1.44 megahertz, which is pretty okay. The next is the 1.7 to 7 megahertz, which is the lower end of the shortwave. And I can see a much more clearer picture as far as the band pass characteristics. The peak is right now somewhere in the middle. I've set it at 6.24 megahertz. On the extreme left is now, this is the extreme left position, and this is at 2.52 megahertz, still a bit higher than the 1.7 it should be at. And on the extreme right, it didn't drop as much, but the amplitude is about 5 millivolts, and the peak is 8.88 megahertz and 43 millivolts. So this is the lower end of the shortwave, and then finally the upper end of the shortwave, extreme left on the capacitor. It's much less, it's not as sharp. I guess this is a linear scale, so you're not going to see that effect. So this peak is at 232 millivolts, which is 0 dBm, almost perfectly there. And then roughly in the middle of the band, you can see it's at 213 millivolts and 20 megahertz. And then to the right, I'm going to take it up to 30 roughly. Okay, so this is roughly on the right edge of the tuning dial, and this is so this is 29 megahertz, and it's 62.3 millivolts. So it is attenuating a little bit on the higher end of each of these bands. Okay, so now this is the just to zoom in into the 0 to 1 megahertz, and you can see now is a much clearer picture as far as the band pass. This peak is at the extreme left. It tunes down to 252 kilohertz. It's still not quite down to 150 kilohertz, so that's the best you can do. And then on the extreme right edge, it's kind of pretty lossy, as you can see. It's just not usable, I think. So somewhere about 3/4 of the way on the tuning dial, it is at 682 kilohertz. I think that's still a little bit too high, so let me bring it back to 500 kilohertz, which is the bottom end of this band it's supposed to be at, and that's a much better signal, and it's 35 millivolts. It's still using quite a bit of amplitude going across the band, as you can see from here to here. It does attenuate significantly. Okay, so now this is the medium wave band, more or less. This is the extreme left over here right now. Extreme left of the tuning dial, we get to 671 kilohertz, which is not quite 0.5, and then roughly in the middle. Note the attenuation changes a little bit. It's not too bad. This is roughly in the middle of the band. It got 1.16 megahertz roughly, and then on the right edge we have to be careful we don't go too far off here. So this is at the upper end, which is 1.5 megahertz, close to the, and then if you go a little bit more, so 1.7, it starts to attenuate quite a bit now. This is almost 1.6, so it's very lossy on the upper end of the medium wave band. Not as selective either. So now if you go to the shortwave, I think this is going to be from 2 megahertz to 7 megahertz, or let's use 2 megahertz. Let's stop it at 10 megahertz just to get some overlap into the upper band. So again, on the extreme left of the dial, it will tune at 2.56 megahertz, and then roughly in the middle it's at 4.6 megahertz, and then on the right, towards the right, it's attenuated a little bit more, not too bad though. And we are at 7.7 megahertz. So, and it can go a little bit more, but I think it starts to attenuate even more. Yeah, so that's no good. So the last band is the upper shortwave, extreme left. Now I'm going to go from 7 megahertz and then stop at 30 megahertz. I'll go to 40 megahertz just to see there's some overlap. Okay, so extreme left, you can see it is tuning quite nicely. So the peak is at, peak not found, okay. So the peak is somewhere around there. It's close to 10 megahertz actually, extreme left. And then as I move into the middle, it's a bit better defined. So that appears to be at 19 megahertz. Then on the towards the end of the band, so this is around 30, I would say. So about 34 megahertz. So you can see it definitely got this low pass, high pass filtering effect towards the lower end, and then it starts to gradually cut off at 30 megahertz. It's a very simple demo of this tuner. It's not particularly sharp tuning, but I think for the purpose of removing some noise in certain bands, I think especially if you're tuning across a very from between medium wave and short wave, it will pretty much attenuate a lot of the medium wave stuff if you are in the short wave band and so on. So it's got some benefits. You just have to be careful that you don't attenuate your signal too much on the edges of these scales, that it's somewhat more lossy than at somewhere in the middle of the band where it's probably been designed to operate at. So this concludes a brief introduction to the MFJ-956. Hope you found it useful.